And now we can infer that the probability of V is active when A is active is higher than the same probability with A is active. So the inequality relationship is obtained as follows. Okay, probability of B equal to 1 given A equal to 1 must be greater than probability of B equal to 1 equal to 0. So this is why the probability value here, theta 1 is greater than or equal to theta 0. And we define the set of the model parameter consistent with that statement as follows. But anyway, theta 0 is in between 0 and 1, and also the theta 1 is in between 0 and 1. Can the distribution of the model in the structure-dependent parameter space become this formula? A Bayesian model here, M, is a combination of two components. The first thing is the structure of the conditional probability between variables. And the component theta is the parameter vector. Okay, the component of which define the entry of the corresponding conditional probability table. Again, we define the probability of the capital X given E and N. Here, when X is in the Bayesian model, there are a lot of there are many variables, the set of variables. So X represents a set of variables, and E is some observation or even evidence that we can set on some parameter values of the variables. And M here is a combination of the structure and the parameter vectors. And next, okay, let me classify the set of available information into an available set of data T and a body of non-numeric expert knowledge omega. There's a measuring PV given A is equal to PA given B times PB divided by PA. And now let me consider A as the set of data and a body of the non-numeric expert knowledge omega. Okay, now the formula becomes PV given M times Pn given omega divided by PB omega. Okay, for simplicity in this paper, we do not consider about the nominator PD omega. Okay, we have only two terms remain, PD given M and Pn given omega. And you can see that PD given M contains the constraints of the model set by the data, and Pn given omega contains the constraints imposed by the expert knowledge. And so we we do not consider about the denominator, so we have the Pn given the omega is equal to Pd given M times Pm given omega. Okay, and now I focus more on the Bayesian inferencing, and you say given some observation or evidence E, okay, the conditional distribution of the remaining variable X is performed by integrating over the model. Okay, integral of the Px given En. Here is the in this equation we think of the observation, set of data, and a non-numeric expert knowledge. Okay, and we perform Bayesian inference by integrating over this term. As you can see, Pm given the omega is this term. Okay, we replace this term here, and we just do it. And we want to make the equation as simple as possible. So, in this case, we do not consider the set of data, so we can delete D here. We can delete D here, and we can delete PD given M. Okay, the equation is this. And M is equal to the set of the structure of the Bayesian network and the parameter, the vector value here. Okay, we replace n here with sk and omega. And if we derive the Pn given omega is equal to P sk theta given omega is equal to this term. Yeah. Okay, and the final equation looks like this. How does it work? I'm thinking about the logical concept and about the mathematical formula that we use to represent the Bayesian inference when we perform Bayesian inference. Okay, for example, only the two cases A and B. In the case S3, okay, A equals B. Okay, under the condition of A is satisfactory. Okay, let us work the probability of having B active. Okay, based on the Bayesian inference, we can perform the other parameter values here. Okay, in this barrel, we consider the three terms in the Bayesian inference equation here. That is SK, this is the model structure, or how the Bayesian network graph structure looks like here. And omega is the list of the qualitative statements about the relationship between entities. It's actually a non-numeric expert knowledge. And the last thing, theta, it is the parameter value. Parameter vector, okay, needed to be specify the conditional probability distribution, okay, given that structure.